Hello everyone. I'm going to introduce here a program for the design of retaining walls. This is a Windows desktop based software. This has a CAD interface on the right hand side and other input panels on the left hand side. This program provides you its GA drawing in a CAD format and then detailed design calculations with equations and sketches, tables, etc. Then this gives you loading diagrams also and output diagrams such as base pressure, bending moment diagram for the walls and bending moment diagram for the base slab, and then gives you a CAD drawing for the reinforcements. Now let us see how to provide input for this program. After the project info page, similar to any other design program, we will go to geometry. Here we have to enter all the critical levels of the program, such as top level of the retaining wall, bottom of foundation, top level of storage, top level of earth on opposite side, etc. in actual survey levels, so that the same will come in the GA drawing. And the height of retaining wall and height of filling, height of water table, all these things will be calculated from these levels. Then the presence of groundwater table is made an option here, so that user can either switch off or switch on. In case if the user switches it on, the input box will become active and the user can input the top level of water on filling side. Then we have the input panel for providing dimensions such as top thickness of the wall, bottom thickness of the wall, toe side offset, etc. Toe side offset is for changing the slope of the retaining wall. Now you can see the sloping side of the retaining wall is towards the filling side. So you can change this input here. So the input can vary from 0 to 600. 600 means the difference between bottom thickness of the wall and top thickness of the wall. So if I change here as 100 mm, you can see that there is a slight slope on the non-filling side also, and the slope on the filling side is reduced. So if I give it as half of the difference, that's half of 600 as 300 mm, then you can see the retaining wall is or stem of the wall is sloping equally on both sides. And if I give it as maximum 600 mm, you can see that the retaining wall is fully vertical on the filling side and it is sloping on the exposed side. So here in this example, we will keep it as sloping on the exposed side. And then you have further inputs like thickness of heel slab near the edge, near the free edge, and thickness of toe slab near the wall edge, thickness of toe slab near the free edge, and then length of toe slab and length of heel slab. Then we have another option for providing heel key. This will help your retaining wall from sliding. Here also the dimensions can be changed. Then before analysis, how will you find out whether the retaining wall base length is sufficient or not? So let us try with 4000 mm and try to analyze the retaining wall. So it says the retaining wall passes, so we will further reduce it. We will reduce it to 3000 mm and then again run the analysis. So it says design failed, check report for details. So on the first page of the report itself, you get a design status. It says stability against sliding is safe, overturning is safe, but maximum bearing pressure is not safe. So if you click here not safe, you will know what happened in the detailed calculations. So your SBC provided is 200 kilonewton per meter square, whereas your actual bearing pressure below the footing has become 214.8. So how to check this before you go into analysis? So you come here and decide here whether you want to solve the heel length or toe length. So heel is normally the slab below the loading side, and then click on refresh graphics if you want to see what happens really in, and then you click on solve heel length. So it optimizes the design and tells us you require a length of 3400 mm. So if you give that, what will be the factor of safety against overturning? That is 3.403, and then factor of safety against sliding is 1.864. Well, you are specifying all your input values here: load factor for RC design, factor of safety against overturning, sliding, and the option whether to check for overturning or whether check for sliding. That you are specifying in a general tab. And once you're back to geometry tab, then you can see here the critical thing for this design is the safe bearing capacity under the footing. So your maximum SBC permitted here is 200, but with this length you are specifying it to 200.6. So in detailed design this might fail. That is happening because of the rounding off here. So we will slightly increase the base length by another 50 mm. You are making it 3450, and then we'll go to loading and soil. So this software can be used for two types of loadings, that is solid and liquid. Solid means the granular fill, so we will go with the granular fill here, and the material name can be input here. Then unit weight of material, I am using 18 here. And then the pressure condition, soil pressure condition, that is active condition and at rest condition. There are two options. At rest condition is normally used for closed basements where a top slab is uh, connected to the top of your retaining wall, and your retaining wall is fully restricted from any kind of movement. This is helpful when you design underground water tanks or basements where the movement is completely restricted from earth fill outside. And there are two types of lateral earth pressure used here: Coulomb's theory and Rankine's theory. In this example we will continue with Coulomb's theory, and there is an option to include cohesion and exclude cohesion. So if you include cohesion, your retaining wall design will be much more economical, but you should have the cohesion value, exact value from the soil reports, and we leave it to the designers. That option has to be decided by the structural designer. And here again we are giving an option for the angle of the fill. If you make it 0, then your top of your fill will be flat, and if you give some 15-20 degrees, you get inclined fill. So when there is a fill, your equation for a coefficient of active earth pressure is not as simple as 1 minus sine phi whole over 1 plus sine phi. So you will get to know that equation when you go through the detailed design calculations. And then you have an option for angle of wall friction, that is normally 5 by 2, but here I am taking it as 0. And then you have another option for additional surcharge loading. Suppose if there is a vehicular movement or anything on this backfill, then you can use this option. And then if you have a cover slab on top of the retaining wall, that reaction can be taken here as additional point load on top of wall. And then if you want to consider propped cantilever effect, you can check this box. We will come to this as a next example. Then soil data for the fill on opposite side can be specified here, including SBC, and passive resistance can be considered here, or you can exclude that. Then seismic design is optional. If you check this box, inputs for seismic parameters will be appearing. And then you give seismic zone, importance factor, response reduction factor, and spectral acceleration coefficient. Then we will go to RC design inputs. You have to specify your grade of concrete, grade of steel, cover, and the crack width checks and the code. The limiting crack width and the code can be specified here. Then inputs such as minimum percentage of reinforcement, maximum percentage of reinforcement, maximum and minimum spacing, round off figures. And some people prefer to give Y for the torr steel, and some people don't give C bar C. So all those changes you can do here. And as per the modern practice, many people provide the horizontal rebar outside, even if it is a cantilever retaining wall, so that the initial cracking due to initial thermal stresses can be avoided. So if you want to do that, you have to switch on this option, so that the effective cover calculation will be done by deducting the diameter of distribution reinforcement. Then we'll go to general tab. These inputs I have already explained in the while I was explaining the geometry. And then here you can select the reinforcement, and then we will go to analysis and design. Since you have already done the proportioning of the heel slab in the first attempt itself, we will get the design in pass. So there are no error messages. You get everything in green. All the designs are either safe or pass. Then we are in the detailed report. We are displaying the inputs and then a sketch of the actual retaining wall. Whatever you see here will come in the design calculations with the same dimensions. There are no errors or mismatches, so that the consultant who is doing a peer review will not have any comments. Then in the detail calculation, you can see the equation for coefficient of active earth pressure. This considers uh, active earth pressure as per Coulomb's theory. You can see how very complicated equation is presented here. And then you get the seismic design calculation also, dynamic earth pressure, two cases, 1 plus alpha V and 1 minus alpha V. Two cases are considered here, and the maximum is taken. And then you have loading diagrams for saturated soil above water table, and then pressure under water table, pressure due to water table, and then pressure due to surcharge. And then comes the stability checks here. Then you get the base pressure diagrams, and then the wall bending moment diagram, then bending moment diagram for the base slab, and then this will give you the design of heel slab, then design of heel key, then it gives you bill of quantities, and then the rebar quantity per meter length, and then cost estimate. If you give the unit cost here, that is the uh, rate of concrete, rate of formwork, and rate of reinforcement. If you give here, that also you will get a estimate per meter length. Apart from that, this program gives you loading diagrams here. These are used in the calculations. You have output diagrams here, base pressure, wall BMD, and base BMD, and then this gives you a detailed reinforcement drawing. Now we will try also the design of propped cantilever effect. Here we will click on this propped cantilever, and again you come to geometry figure. Here our heel slab length is 3450. So since we are going for a propped cantilever effect, we have to click on at rest condition earth pressure. After that, we have to come here and solve for heel length. So instead of 3450 mm for the heel slab length, this will give you a much lower dimension here. This time it gives you 1900 mm, probably 1700 mm. Yeah, and this time see maximum SBC is less than 200. Factor of safety against sliding is gone up 1.6. Factor of safety against overturning is 2.7. So both the values are more than 1.4. So in the first attempt itself, your design will be safe. Let us try that now by clicking on the analysis and design button. See, you are getting all the designs passed in the first attempt itself. Let us see how is the wall bending moment diagram here. See, you can see the wall has some positive bending moment diagram also this time, and the value of the maximum negative value is also reduced. Here also this gives steel on the opposite side, extra steel on the opposite side to cater for the positive bending moment diagram. All these values, the diagrams can be saved as AutoCAD drawings, and the GA drawing also can be saved as AutoCAD drawing. Thank you for watching.